Po twojej pysznej zupie nie ruszam dupy z klopa, ta zupa była z mlekiem, na mleko mama.
Hello, guys. Welcome to a Python platformer project. This is going to be a complement to the class that I'm teaching live on 5 o'clock to 6 o'clock p.m. on Saturdays. So, this is just going to be what we go over in class, and for any of you guys that just can't make it or aren't in the Discord server, be sure to pop by and take a listen. You don't have to stay for the entire time. You might learn something. But we're going to be making a Python platformer project. So, in case you don't know, Python is a coding language that is very easy to learn. It is probably one of the, if not the most used coding languages on Earth, and very geared towards beginners. But it also has very advanced concepts, so very easy to understand, but also very powerful. A platformer is a type of game that is just basically you control a little avatar. We're going to be making a box. Maybe we'll make a custom design avatar later. So we're just going to be making a small box that just jumps around on platforms and stuff like that. So why don't we get started? So how we get started with Python is we just right click here, hover over new, and we're just going to make a folder. We're going to call this Pygame platformer. So there are a couple of things that you need to do to set up before you get started coding. So we're going to need some resources to help us. They're like language add-ons, right? So we're going to need two packages. So we're going to come over to our command prompt, and in case you don't already, you need to download Python. So how do you download Python? We go to the Microsoft Store, come over here, and we open this up. If you're on Mac, I think there should be a Mac equivalent. And we're going to come over here, and we're just going to type in Python, and it's going to pop up, and we're going to install Python 3.8. So Python 3.8 is the latest version of Python, and it's taking a while to load here, but it should load up. You're going to click install, and it will download. So the Python 3.8 is pretty much just an app on your computer that will let your computer understand Python code. And then you can open up any text editor. I use PyCharm, but you can use VS Code or anything like that. Uh, and after that, we need to do some installations. So come over here. I'm on my user folder. You can really be anywhere. But what you want to do, you want to type in pip install Pygame. And there should be a loading bar. Of course, I already have it, so it's going to say requirement already satisfied. But there should be like a little loading bar up here. It might take anywhere from 30 seconds to 10 minutes, depending on how fast your internet is and how close you are to your router. But once you have that downloaded, we're also going to do pip install keyboard. And of course, I already have it, but you guys also want to install keyboard. So what is Pygame? Pygame is a add-on for Python that allows you to basically have more tools at your disposal in order to be able to, for example, make a new window to draw visual stuff to. You can draw rectangles, spheres, you can draw images to the screen even. So that would be useful for custom textures. And keyboard is a key detecting app, so it can detect when you're pressing whatever key you're pressing. There is a native Python one, but I prefer to use the third-party one that is specially designed for just detecting key presses. Okay, so once you got those two installed, you're ready to get started. So we're just going to come over to our Pygame platform folder. We're actually going to open up our IDE of choice. So this can be PyCharm, it can be whatever coding you use, or coding software. It can be VS Code, which is a text editor, Sublime Text, I think Notepad++, or if you guys don't want to download anything, you can just use Notepad. But we're just going to come over here, and we're going to open up PyCharm. And we can get up. We're going to click File, and we're going to click, Open. And we're gonna open up we're gonna navigate over to our Python folder where we want to make it. And I think it's somewhere over here, Pygame Platformer. And we're gonna open it in this window. So you can see what it did is it came over here and it made a main.py file and a .idea file. The .idea file is only for JetBrains products, so IntelliJ, PHP Storm, WebStorm, RubyMine, PyCharm is obviously one of them. Any of their products, they have a .idea file. This is just for some custom settings that you have. This will not be any relevant to anything that we code. But the other thing they made is a main.py file. So what this is it is a file that you're gonna code in. So how do we run this file? We can just double click it and it's gonna pull up command prompt. It's gonna run. You can see it pulled one up on my screen and then it closed it immediately because of course we don't have any code down yet. You can see right here all we have is this, and this is just what they automatically put in there. We can just delete all of this because we don't need it, and we're going to get started coding on Python. So we're going to need to import a couple of things. So what is importing? Well, importing is the action of bringing in extra tools you need to use. For example, let's say a construction worker. They would want to bring in, let's say they're building a skyscraper. They want to bring in cranes. They want to bring in cement pouring trucks to pour the foundation and stuff like that. We're doing that, so we're going to want to bring in some stuff. We're going to do, right now, import sys, which is system, and we're also going to import, and its new line's not working. Import Pygame and import keyboard. So this is the three that we're going to use right now, and basically what these three do is Pygame is of course the one that we described, where it's the one that you draw to the screen. Sys is just some system tools that we may or may not need, and keyboard is the keyboard, the key detecting presses. So we're just going to come down here. The first thing you need to do is pygame.init. Two parentheses after that. So what this is going to do is, you can see right here, it lights up. This is saying, okay, you're using Pygame. You're using these tools in your coding. So pygame.init is just something that you do in order to start Pygame. Say, hey, wake up. We're going to use you now. So yeah, we're just going to do that. Come up here, and we're just going to create a new line down here, and we're going to define some variables. So we're going to define the color black as 0, 0, 0, which is in RGB is the color black, in case you didn't know. We're going to define the color red as 255, 0, 0, because of course red, green, blue, the red part should be maxed out, which is 255, and of course we're going to define green as 60, 255, 0. So of course you might say RGB green, why don't we just have 0, 255, 0? Well, that green is kind of a bit too neonish. Of course, we can always just adjust these later if we want to. We don't have to stick with these. So we come down here. We're also going to define some other variables. X is equal to 25 and Y is equal to 25. So what these are is, these are going to be the X and Y values, or actually no, these are going to be the X and Y values of our player. Actually, no, let's make this 250. And let's make this 375. So this is pretty much going to be the one corner of a rectangle that we're going to draw for our player. So this is going to be the top left corner of the rectangle that we're going to draw from the player, and of course we have to draw the rectangle. We're going to have to define the rectangle size. So we're going to do rect width. This is going to be equal to 25, and a rect height is going to be equal to 25 as well. So our rectangle is going to be 25 by 25. It's going to be red, and it's going to start at 250, and it's going to also start at 375. So 250 is going to be the X, so left, right. It's going to be 250 pixels in from the left, which is in the middle of your screen, and 375 from the top, which is going to be almost at the bottom. And why did I say 250 is the middle of the screen? Because obviously my screen is like 720 pixels wide, right? Well, we're actually going to define a smaller area, a smaller region inside of your screen to use as the game. So why don't we start that now? Screen equals pygame.display.set underscore mode parentheses. We have another set of parentheses inside of here. Oops. And we're just going to do 500, 500. So our screen is going to be 500 pixels long and also 500 pixels tall. Okay, that's great. So why don't we come down here, and Also, this complicated stuff right here, pygame.display.setMode, this is what we call a function. So this is pretty much telling Pygame, which is the one right here, where you're going to tell him, hey, call up your buddy display, your child display, and tell him to set the mode of your screen to 500, 500. So this is just setting the size and making a screen to draw to. We're also going to add a ground variable. Wait, actually, let's hold on. Let's hold that thought. Why don't we take a look at what we're doing? All right, wait, we've done. Oh, look, a window pops up, but it instantly closes, and everything just instantly closes out. That's not good. We don't want a game that whenever you run it, it just instantly closes. Well, I mean, no one will use that. No one will play that game. So we got to come down here to the very bottom, and we got to do some other things. We're going to do screen.fill black. So you see how we defined a variable called screen right here? Well, this variable screen, it has a few tricks up its sleeve. We're going to tell it to, okay, we're going to tell it, okay, fill yourself to black, and then we're also going to tell it to pygame.display.flip. So what this is going to do is it's going to just refresh the display whenever it's called. So we want these to be running all the time. So we want this to be running pretty much as soon as any change happens, it just runs. So we're just going to want to put this in a while loop. So while 1, and we're just going to tap these in. So what this while 1 is it's just going to continuously run. It's just going to keep running all the time. Now in regular coding, this would be pretty bad. You wouldn't want a while loop running all the time. But in game coding, this is actually okay. Because some things we want to run continuously. For example, we want to refresh the screen as soon as possible to update any changes and make the latency as low as possible. We also want our game to be always detecting key presses, so we want that to be in a while loop as well. We want the game to instantly make any movement changes, so that's also going to be in the while loop. And for example, any enemies that might come onto the screen, we want that to be in the while loop. So there's different use cases for game design and regular application coding. So why don't we try and run this thing again? Okay, well that's better. You see our screen is just black, which is because we drew it black, and it's saying not responding. Well, that's not good. So we're gonna add another code. So the reason why it's not responding is because Windows is detecting, hey, nothing's changing. They're not running any other code except for this stuff. So nothing's actually changing on the screen. So I'm just going to say this program is not responding, and I'm going to end it. So we don't want that to happen, so we're going to make sure that it keeps changing. So how we do that is we're going to add a for event in pygame.event.get colon, and we press enter if event.type is equal to pygame.quit colon break. So what this is going to do is it's going to detect when the screen is going to force quit. So pretty much when Windows is going to force shut down our Pygame thing, our Pygame screen, and it's going to just say, okay, we're just gonna break out of this. We're gonna say, hey, we're doing something. So it's like when let's say you're in a university and you have automatic lights that turn off after a while when they don't see any motion. If that happens, you just wave your hands around, you get up and you just like walk around a bit so that the lights turn back on. Well, this is the same thing. Whenever Windows is like, hey, this program isn't doing anything, it's going to just get up and wave its hand and say, hey, I'm doing something. And then the Windows is going to see that. It's going to say, oh, yeah, you're doing something. Great. And then it's going to it's not going to shut down the program, basically. So why don't we start? And we can instantly see we can drag this window around now, and it also doesn't instantly shut down, which is good. We don't want it to instantly shut down or crash. Okay, so what's the next part? Well, we kind of need to get a ground for our little character guy to walk on. So we can do that by writing this simple line of code. Ground is equal to Pygame dot rect capital R 0, comma 400, comma 500, comma 100. So what this is doing is it's defining the the upper left hand most corner, which is going to be situated at 0x, so the very left hand, and 400y, which is 100 pixels up from the bottom of the screen, and then the length and the height. So length, or width in this case, would be 500, so it extends across the entire screen. The height is 100, so it's going to extend downwards by 100 pixels to touch the bottom of the screen. If we run our program now, you can see, oh, nothing happens. We made this object here, the ground object, but we didn't actually draw it to the screen. So what we're gonna do is right above this, or right below this actually, we're gonna do screen dot fill parentheses green comma ground. So what this is gonna do is it's going to after the screen fills with black, it's going to fill it with fill whatever the ground object is. In this case it's this rectangle with green. And why don't we, and of course we define green up here as being 60 to 55, comma 0. So if you don't have a green variable defined, you can also just do parentheses 60, comma 255, comma 0. But we do, so we don't need that. Green. Okay, why don't we pull this up, main.py, and we have a ground now. You can see it's a pretty neon, vibrant shade of green. That's fine, we can always texture it later to look more realistic. But for now, why don't we draw our player in? Of course, we need a player. We can't just pilot nothing. That wouldn't be a very interactive game now, would it? So why don't we come up here, and we already have kind of all the stuff that we need. So we're going to do another thing. Right below this, we're going to do pygame.draw.rect parentheses screen, comma, in red, comma, and then we're going to draw x, comma, y, comma, rect width, comma, rect height. So what this is going to do is, how this works is it draws, oops, I gotta add spaces back here, and back here, and back here, get rid of these. So what this is doing is it is drawing a rectangle on screen that is red, and it is going to draw this. So x, y, rect width, red height. So this is going to be the top left corners, and then we're going to have the rect width and rect height, which is I'm having a 25, 25. So of course we could use this, but I feel like this is a bit better. Just because we have to keep updating it, and it's easier to just update a variable that's up here instead of going into a class and updating that. So it's just one less layer of abstraction. Why don't we come over here and let's run that. And you can see we have a little red box right here, which is good. We want that red box. This is ideal, so we can just close this out, come over here, and now we need to be able to move the red box, because if it's not moving, that's a problem. Your game's not very interactive. It's just the ground and a red box that you can't move around, right? So we're gonna come over here and we're going to make it move left first. Or actually no, let's make it move right first, because I think the right moving thing is a bit easier. So let's come over here. We're gonna type in if keyboard dot is pressed. Oops, if I can type. Quotes, capital D, colon. What does I can't spelling keyboard. So what this is gonna do is it's going to detect if the keyboard is being pressed, the D key specifically. And since this is running constantly, it's going to detect constantly if your D is pressed, your D key. And that's what we're going to do this. If x is less than 500 minus rect width colon. So what this is going to do is it's just going to prevent the player from moving all the way off the screen. Just so that once it gets to where it's right against the edge of the screen, it's going to just stop moving. And then we come over here and we do x is equal to 1. Or actually no, x is plus equal to 1. So what this is going to do is when we press the D key, it's just going to add 1 to x, which is currently 250. And how that works is basically it's just going to add 1 to x and it's going to draw that. So every time the D key is detected to be pressed, it's going to move 1 pixel to the right. The player is, I should say. And we come over here, we can run this code, and oh, I can see it moves right. But I can't move it back because my A key isn't programmed. So why don't we program that? It's basically the same logic. If keyboard.isPressed A colon if this is different, x is greater than 0, then we say x is minus equals to 1. So this is moving at 1 pixel per second, and now we can move right. And then again, we're just stopping it short where it touches the edge of the screen. Alright, well that's great. So, why don't we come over here, and it's moving a bit fast currently, but that's fine. We can always fix that later with some tuning. Why don't we add jumping mechanics? We're going to have to create some more variables. So why don't we add a velocity variable just so we have a global velocity modifier. So we can just change this. And we're just going to say velocity and velocity. So we'd also have to edit some things. This minus vector width, we're also going to have to subtract velocity. And if x is greater than velocity right here. Because if we had a velocity that was greater than 1 pixel, let's say we have it 6 pixels, right? Then it hops to the right or the left 6 pixels every frame. Now, that's a problem because if we were 6 pixels, or if we were like potentially 5 pixels away from the edge of the screen, and we hopped 6 pixels to the left, well then we're off the screen, which is a big problem. So we have to do rect width minus, or 500 minus rect width minus velocity to make sure that our our character doesn't hop off the screen. So why don't we run that again? You see, okay, it still works, but now we just made our code a bit cleaner. Something else I wanted to do is just have a screen width and height. So we're going to add a screen width is equal to 500, screen height is equal to 500, and we're just going to change these up. Screen width and screen height. And we also have to put these above because they need to be declared before, just so that they knows what it is. So why don't we come over here? Let's see if that still works. And it does. Great. So now instead of having a 500 over here, we can just have screen width. So now we can feel free to like modify this to like 1,000 by 1,000. And this down here should actually be 0, and then we need to be screen height minus 100 and screen width, just so that it's always 100 pixels off the ground. And you can see here, we just quadrupled the size of our screen. It can't even fit on my screen vertically anymore. And it's still, our rectangle still starts in the same place, which is a big problem. Why don't we fix that? Let's make this actually, let's say like 700. 700. So x equals 250, that is obviously not okay. We do x equals screen width over 2. Obviously, we have to have screen width above this, just so that it knows what screen width is. Because if we had screen width below, below whatever x was, then we declare x first, and then we make screen width a thing. So it's not going to know what screen width is. It's like a time traveler, right? So you can't, it's just, it hasn't happened yet. So y equals 375. Why don't we do this? Y equals screen height minus 100 minus player, or minus rect height. But obviously rect height isn't a thing yet, so we just cut these out and paste them above it. Okay, Pygame platformer. Let's run this. And you see, look, our screen is way bigger, but our ground is still there. So we do have a deprecation. We do have a deprecation warning. Integer is required. You got the type float. So pretty much what it's saying is it needs a whole number, but we put a decimal into it because we did 700 divided by 2, and it always has a bit of leftover. That's just how computers work. It doesn't want that leftover, so why don't we do something like this? Import math. So we do this to make sure that everything is a whole nice and round number. Math.floor. This. So what this is doing is it is making sure that whatever is being put into x or y is an integer. It rounds anything down to the nearest whole number. So if it's 2.9, rounds it down to 2. If it's 1001 or 1000.1, it rounds it down to 1000. So why don't we just run this code again, and we shouldn't get that warning. As you can see, it's fine. So our character can move around, but it can't jump. So why don't we add some jumping code? Let's come over here. We need to create some more variables. So we're gonna do is jump equals false. So what this says is pretty much, is your character jumping currently, or what it's going to say, at least once we code it. And we're also going to do a jump count to be 10. So this is going to be how high it's jumping. Also, I'm going to change all of my variables to camel case, just to make sure it complies with whatever standards people have. So camel case is pretty much, first word is lowercase and all other words after that is capitalized, and they call it camel case because it looks like a camel. So yeah, this is a bit boring, but people usually like coding people like standards, and camel case is one of those standards that people like. They like everything to be neat and tidy. I think that's all the camel case that we need. Yep. So why don't we come over here? Because the reason why people use camel case is because obviously you can't have a space in your name for variables. You can't have a space when naming anything in computers. So you must make do. There's obviously like something like jump underscore count, but that's just too clunky, and you don't want to reach for the underscore key every time you type in your variable name. So people instead just capitalize the next letter. Why don't we start coding? All right. So we want to come down here. We're going to say if not is jump. So this is saying if jumping is if jump is false, then we come down here. We say if keyboard dot is pressed, and I want this to be W. W. Then we come down here and we're gonna say y minus equals. Oh no, not that yet. Not yet. We're gonna say is jump is true. So this is just gonna set is jump to true. That's all it's gonna do. And that's all we need currently. Then we're going to come down here and we're going to say else colon else if jump count is greater than or equal to -10. We will do this. Y minus equals jump count times the absolute value of jump count times 0.5. So pretty much this is a quadratic function. So this is pretty much saying x squared times 0.5. So the reason why I want a quadratic function when we're jumping is because a quadratic function is reflecting how the velocity of the jump will go. So we're going to go fast, and then once it gets to the top of the height, or the top of the jump, it's going to gradually slow down, and it's going to hit 0 velocity, and then it's going to come down here, it's going to have negative velocity, and it's going to start going downwards. So a quadratic function is usually the one that we need for jumping. Otherwise, your jump is going to look really weird. For example, it's just going to go straight up at the same speed, and it's going to stop, and it's going to go straight down at the same speed, which is obviously doesn't look natural, doesn't look good. So yeah, we're subtracting that from y, of course, because that's how we make it go up and down. So it's going to start off as negative. No, it's going to start off as positive. Then after jump count gets decreased by 1 by 1 by 1, then it's going to go to negative. So it's going to start off as 10, then jump count is going to go to 9 to the 9th times half, then 8 to the 8th times half, then 7 to the 7th, then 6 to the 6th, then 5 to the 5th, then 4 to the 4th, and so on and so forth, until it gets to negative. And then it goes to -1 squared, then -2, or -1 to the 1, then -2 squared, then -3 cubed, -4 to the 4th, and so on and so on and so forth, until we get to -10, and then it's going to be where we started. So we're also going to come into here. We're going to say jump count minus equals 1. So this is the subtracting 1 I talked about. So it's just going to go from 10 down to 0, down to -10. Then it's going to go reset itself, which is where we're going to add later. Or right now, actually. Else colon jump count equals 10. And is jump is equal to false. So once the jump count gets below 10, so it gets to -11, it's just going to stop this code right here, and it's going to run this code. It's going to reset it back up to 10, and it's going to set its jump to false, because it knows that you're back where you started. Then we're also going to come over here, and we're going to do, we're going to import another thing. Import, actually not now. We're going to worry about it later, because that is going to be something for a later in the video. Let's see what else we want to do. So we want to come down here. We also want to do some rounding over here. Math.floor this and math.floor this, because we sometimes have negative values. For example, if we want to make the velocity below 1, like this, we're going to want to floor this so that it doesn't move half of a pixel, which is obviously impossible, and it's going to crash itself. So we're going to come over to Pygame Platformer. We're going to start this, and we can move left and right. We can also jump, but you can see this jumping is too fast. It's splitting into 3 of them at once, which is obviously not ideal. So we're going to want to slow that down a bit. So we're going to do import time. So time is just time functions. For example, you can tell your program to give you the date. You can tell it to sleep, which is what we're going to do. Or you could tell it to, of course, give you the time. So we're going to come over here, down here, we're going to do time.sleep, 0.01. So this is going to sleep for 1/100th of a second after everything is done. So what time.sleep does is it just freezes all code that's running. So it won't run this while variable or this while loop. It won't run anything. So obviously this presents a problem once you start getting to slower and slower times. Your game gets really stuttery, but for this slow of a time, you can see it's fine. It's like okay. You can see that helps a lot with just the glitchiness of the code earlier, where it was just splitting into like it was going so fast, it just split into three separate boxes. Uh, why don't we bring that up to 0.2 just to see how it goes? And you can see that's even better. Of course, you can't really you know, you can't really move when you're jumping, but that's a problem for another date, as they say. So, uh, that's why we mathed out floor these, and we're gonna just divide the velocities by 2, because also the moving left to right is a bit fast. It's really hard to control. And you can see, okay, now we move at a more respectable pace, and we also jump at a more respectable pace. And this also actually doesn't affect the jump height at all. It just slows it down, so you just can't jump as quickly. So that's basically it for the first episode, I want to say. Um, so we nailed the movement. No guarantees what we're gonna do in the next episode, but maybe it's gonna be some textures, maybe it's gonna be some extra platforms, so we can actually make a platformer game. Maybe we're just gonna polish up some of the stuff that we made. I don't know. It depends on where we go. Tune into the class if you have time. If you don't, you can just watch the videos. But I'll see you guys later. Goodbye.